Am I audible?
Yeah, I can hear you. Can you hear me?
Just a
So today your friend will join or not? Harsh?
Yes, yes, yes. Now I can hear you.
Okay,
I'm uh, I'm calling the other person.
okay.
కాల్ కోసమా అని చెప్పి కాల్ చేసిన హర్ష. తొందరరా. రైట్ రైట్. He'll be there in 5 minutes. Yeah,
Okay.
2 minutes probably.
So we will continue start and he join then we also join him, no problem.
Yeah, yeah. So you have sent me the uh, layers it is showing for Hyderabad,
Yeah,
but
I share my
when
screen.
I put run,
Okay, actually you can
it is.
see. Okay, I will understand your thought. So
Yeah,
actually you
yeah,
can see this is your shape file, and this shape
yeah.
file I uploaded in my own asset. Okay, you can see this is my asset, and this
Okay,
asset is only for my own use. Okay, privately, and if
okay.
I will not share with you, then you cannot access. Okay, when I will share it, then you can easily access this code. You can see this is your shapefile line of this code, user, then my email ID, then your this shapefile name. Okay, so when I
Yeah,
share this ROI or share the boundary shapefile or share my
okay.
asset with you, then you can access, otherwise you cannot access. Okay, I will share you can easily share it. You can simply find out the shapefile from your asset. Your asset name is that you can see ZSM. So I
Mm.
simply find out my asset from here. This is my asset. Okay, this is my shapefile. So here you can see this is a button for the share. Okay, when I simply click to share, and if I have any specific person I want to share, then I can simply put here email address or anyone can
Yep.
read. When I simply click to anyone can read, then click to the done. Now anyone can access this shapefile. Okay, so when I simply go to this link go to this link, then you can easily access the shapefile. So now you can try it.
Now I got it.
Okay, now
Now
my
I got the shit.
okay, so now my share will be, my asset will be shared with you, or any person can, when they are go to this link, they can easily access.
Okay. So, like you, over a period of time, I want to take the values for the whole year, for whole 2020 to 2021, and wanted to calculate the local level PM 2.5 thing.
Yeah,
So, is there a possibility, like by using satellite image?
so PM25 concentration, I think we can use here the Landsat or Sentinel imagery for making the PM2.5 concentration. Actually Sentinel 5 it's not available for the PM2.5. You can see I will
Okay.
try to show you that Sentinel dataset. Sentinel 5,
Okay.
this Sentinel 5 you can easily access the sulfur dioxide, then offline ozone, then nitrogen
Uh,
dioxide, then aerosol index,
uh,
then sulfur dioxide, carbon monoxide, then formaldehyde, then nitrogen dioxide, then aerosol layer height, then methane,
what
then
is aerosol layer height?
okay, so you can see what is this.
Is that something related to boundary layer?
So this dataset provide the offline high resolution imagery of UV aerosol index, UVAI, also called the absorbing the layer height. Okay.
Like, will it tell what is the height of pollution concentration at different heights?
Yeah. And here you can see this is the band, aerosol height, aerosol pressure, aerosol optical depth. We can easily access all of the things, all of the bands from this dataset.
Okay.
Actually all of the process will be same, just you can filter, reduce, and all of the process will be same. Okay, I hope after 7 days you can easily explore all of the things, all of the data set. Okay, also the carbon monoxide, formaldehyde. Okay, you can see that tropospheric ozone, then cloud. Okay. But PM 2.5 concentration is not available, but it also possible for calculating the PM 2.5 or PM 10. We can easily calculate it using the different types of algorithm. Actually this dataset will not derived from other Google Earth Engine dataset, but you can see all of the dataset, sulfur dioxide, other gases, it will be already in Sentinel-5 dataset. Okay.
Okay.
Okay, he'll join. Okay, so now we will start. Okay.
Yeah.
Recording in progress.
Okay, so basically third day we also continue from the third day, and then move to the, if we have get time, then move to the fourth day session, no problem. And third day we also talk about this type or the filtering and displaying the Sentinel-2 satellite imagery, and we also try to monitor the NDWI. Okay, so in this time I will start from here. So first of all you can see, I will repeat again in here. First of all I import your shapefile, boundary shapefile. Then I also show the layer of your boundary. Okay, so you can see this is your layer for boundary, this is your boundary. Then I simply call my Sentinel-2 satellite image collection. Then I use here the filter bounds function for intersecting your collection with my region of interest or my shapefile, so that it will be intersect. Then I simply use here the filter date for my specific time period. Then I want to filter my image specific image properties. I want to need only for this images with image cloud pixel percentage less than 1%. I take it, and I can get here more. I think we will get from here the more than some image, and from the all of the images I can calculate the median image. Okay, then it will be clip with my shape file. Okay, and then I simply show my image. You can see this is my image. Okay, now we can use the different types of remote sensing work using this satellite imagery. If you want, you can make the land cover classification map. If you want, you can make the NDVI map, NDWI map, or whatever you need. You can do any remote sensing analysis using this satellite imagery in here. Okay, so now I want to calculate the NDWI. So NDWI, this is the formula for the green subtract with near band, then divided by green plus near band. Okay, so in this time I simply select my band. Okay, you can see here this is my collection, this is my image collection, and it will be stored in a variable s2a. This is my variable. Okay, and this image collection has the total 17 bands. Okay, total 17 bands. From the total 17 band I want to select only for the near and green. Okay, because I want to calculate the NDWI, and my NDWI need the two band, green and near. So then I simply put here the, you can see I simply take a variable NDWI, then I simply put my equation green subtract with near divided by green plus near. Okay, I can simply use the equation. Okay, and then I simply put here, you can see I show the NDWI layer in here, so that this is my object name NDWI. I simply put my object name, and this is my visualization parameter. Okay, so in this time you can see here you take the mean pixel value for the NDWI. It will be start from the -1 up to +1. Okay, and then I simply put here the color plated, which pixel value is the closer to the -1, it will be showing the red color, then up to -1 it will be yellow, and then up to 1 it will be showing the blue color. Okay, so now I simply click to the run. You can see I can get the images, and we already know about that the NDWI, the positive pixel value, it's defined the water. Okay, for NDWI, okay, positive pixel value, it's defined the water surface in here. So here you can see I want to check the pixel value for the water, so it will be you can see everywhere it. So here you can see, suppose this we can identify this is the water body, and if their pixel value will be positive, then we can identify this is the water body. Or urban or built up area or other things, it will be showing the negative pixel value result. So I simply click to the inspector tab and click on this. Here you can see now I can get this value. You can see we already know about that. For the NDWI, positive value define the water pixel. Okay, so we can get the positive pixel value from here. So if we are it, you can see. Okay, so now you can see we can get the 0.23, so positive value. Okay, so if you have clicked any vegetation or other things, suppose I simply click here, we can get here the negative pixel value. So negative pixel value, it's determined there is the no water. Okay, you can see we can get the negative. Okay, so it means that this pixel this place there is the no water. So mainly this is the process for calculating the NDWI, and if you want you can also calculate the NDVI. This is the totally same process. So first of all you need to select the band for NDVI, and we already know about the NDVI. What is the equation for NDVI? I simply write the equation NDVI. NDVI equation is the near band minus red band divided by near plus red band. So this is my equation. Okay, so first of all I need to select my band. So here you can see here I already select the near band. So in this time it's not needed for the again select the near band, because I already select my near band. Okay, so now I need to select only for the red band. So I simply take a variable and give the variable name is the red. Okay, and you can see this is my collection, and in this collection we can get the total 16 bands. You can see 16 bands will be available here. All of the band will be available here, B2, B3, B4, or red, green, blue, near infrared, shortwave infrared 2. All of the band will be available here. From the 16 band I want to select only for the one band, this band called the red band. I simply call my variable name S2A and paste here. After this I simply use here the select function, and what I select, I want to select the red band. I want to check what's the red band variable name in Sentinel-2. I simply paste here. You can see, so I simply go to here. You can see red band, this red band name is the B4. I simply use the B4 in here, so I simply put here the B4. Okay, so now I want to write the again equation for the NDVI. So I simply take a variable and give the variable name is the NDVI. Okay, and after this I simply put here the equation. My equation is the, you can see, green near minus red. So you can see this is the near, this variable is stored at the near band. So I simply put here the near, it will be subtract with the red band, then it will be divided with near, addition with red vent. Okay, so I simply put my equation. So now I want to show this map in my layer for NDVI. So I simply put here map dot add layer, and after this I simply call the NDVI and then click to the run. So now you can see it will be appear, right? Okay, so I think some wrong in here. Before, okay. Then click to the run.
So I wanted to ask you this. Normally,
Yeah,
if something goes wrong in the process, in GAs, what we do is we have a catalog box on the side, right?
yeah.
So do we have something like the same in here? No?
Yeah, this is the same way, because you can see this is the raster calculation. Okay, so when you want to work with the ArcMap or QGIS software, you need to select a specific band, then we need to calculate it in here, but we can easily calculate it in here. You can see, just I write the equation, I can get this result. Okay, and if you want, you can also download it this image as a tip format. Suppose I want to need the tip image for NDVI or NDWI. I completed all of the process from my Google Earth Engine platform, and then I simply download the tip image. Then I simply open this tip image in my ArcMap software or QGIS software and making the map. Okay, so here you can see, here I already make the map. You can see, so you can see this is the map, and in this map I will do everything in my Google Earth Engine platform. Okay, then I simply download the tip image, then I make the map layout for my research purpose work or presentation work. Okay, okay, so now you can see here our NDVI map will be appeared, and now I want to show the visualization parameter in here. Okay, so I simply use here the visualization parameter in here. I simply put here, you can see I want to put here the visualization parameter. I want to show here the mean result. Sorry, I want to show here the mean pixel value. It will be showing the up to plus minus 1, and max pixel value up to plus 1. And we already know about that NDVI is the monitoring the vegetation. Okay, so upper positive value or upper positive value, it's identify the vegetation, and lower or negative pixel value, it's showing the water or other things, not vegetation or urban. Okay, so I simply use here the plated like this. I want to simply make a list in here. I want to show which pixel value is closer to the -1 or -1. It will be showing as a blue color. Okay, so I simply put here this blue color in here, because I want to show the blue color. And then up to greater than -1, but less than +1 pixel value showing the white color. I simply put here the white, and closer to the 1 and 1 pixel value, it will be showing to the as a dense vegetation. I want to show the dense vegetation will be green color. I simply put here the green. Okay, and then click to the run. So now you can see it will be showing. So dense vegetation will be showing as a red green color, and other things built up area or water body, it's showing as a white color or blue color, mix of the white and blue color like this. And if you want, you can also check, and I also give the rename. So this is the name for, I simply put the rename, and this is my NDVI. Okay, and I also put here the layer name. Suppose this layer, first layer, it will be showing the NDWI. I simply put here the NDWI, and also put here the another layer is that this is my NDVI. Okay, so now you can see here the NDWI and NDVI two layer will be appeared. And if you want to check the pixel value, dense vegetation pixel value showing the positive pixel value. Okay, so I want to check from here, this image will become, you can see. Okay, so I simply click on the inspector, and I simply click on any green pixel value. So I think there is the very less vegetation, so that's why we cannot show the more green pixel. So I simply click to here. So now we can see NDVI positive value, we can see we can get the NDVI positive value, but in this place we can also see the NDWI negative value. So it means that you can see NDVI 0.5, it means that there is the vegetation, and NDWI negative, it means that there is the no water. Okay, and if you want, we can also calculate the NDVI. NDVI is the normalized difference built up index. So mainly NDVI is work for identify for the built up feature or your urban feature. Okay, we can easily use this equation, and this equation is that I simply put the equation. Suppose NDVI, this is the normalized difference built up index. Okay, so this formula is that we can say that NDVI formula is the short wave infrared band, is SWIR, short wave infrared band, minus then we can say then near infrared band. Okay, short wave infrared band, then near infrared band. I simply put here the near infrared band, and it will be divided with the short wave infrared band plus near infrared band. Okay, so mainly NDVI, it mainly used for the identify the build up index, and and when I check this NDVI, this pixel value, this positive pixel value identify the build up area. Okay, this positive value, this positive pixel value identify the build up area. Okay, so first of all we write the equation in here. Suppose I simply put the equation. So my equation is that NDVI, so NDVI. Okay, and this equation is that, okay, you can see here in this time I want to need the short wave infrared band and near infrared band. My near infrared band already selected. In this time I need to select the only for the one band, short wave infrared band. Okay, so I simply take the another one variable and give the variable name is the short wave infrared band, and I want to select this band from the S2 collection, because this collection already stored there total 16 bands. From the 16 band I want to select only for the one band. This band name is that short wave infrared. I want to simply select what is the name of the short wave infrared band. You can see, so short wave infrared 1, you can see short wave infrared 1 band, it's named the B11. This is the band for short wave infrared band. I simply copy the band name and paste in here. Okay, so now you can see here I selected my required band, near short wave infrared band and near infrared band. So now I simply write the equation is that, my equation is that I simply put here the short wave infrared band, it will be subtract with near infrared band. Okay, and it will be divided the sum of the two bands. So I simply use here the short wave infrared then it will be add with my near infrared. So this is my equation, it's done. Okay, so now I want to show this map in my layer map in interactive view. I simply put here the map dot add layer, then I simply use here the ndvi. So mainly these all of the indices will be very helpful when you want to make the land cover classification map for identify the different types of feature. Okay, so in this time I also try to show you the calculation, but when you want to work with the land cover classification map, then we also refit all of the band. Okay, so I simply click to the run. So now I can get the result for ND build up area. You can see. First of all, we can get here the totally black and white color map because we did not add any visualization parameter. Okay, so you can see it will be appearing, and you can see here. And now I want to add here the visualization parameter, then check the pixel value. Okay, so I simply make a visualization parameter. I simply use here the curly bracket, and I define here the curly bracket. I define here this. I want to simply select it is the mean pixel value. It will be start from the -1 and max pixel value up to +1. And I also define here the color plated. I make a list in here. I want to show, oh sorry, so it will be plated, PALE color plated. I define here this list. So in this list I simply put here which pixel value -1 closer to the -1, it will be showing the green color, so it will be not built up area. So I simply use here the green color. Okay, then which pixel value greater than -1, it will be showing the yellow color. I simply use here the yellow color. And which pixel value closer to the 1, okay, and greater than -1 or greater than negative value, it will be showing the red color. This is my build up area. Okay, so I simply use here the red color. Okay, so now I want to also provide this layer name is that ndvi. Okay, and I also rename this here. I also simply use here the rename function, rename, and put the name is the ndvi and click to the run. So now you can see for the ndvi our build up area showing as a red color or red yellow mixed color, showing the pixel value. So you can see what's happened. You can also see there is the 3 layer ndvi, ndwi. Okay, so now I want to check. Suppose I simply click on inspector tab, and we already know about that ndvi result will be positive value. Okay, so which pixel value will be positive, it will be showing the means there is the built up area. So here you can check, we can get here the positive value. It will be showing this is the built up area. Okay, and there is a lot of build up area. Okay, and you can check this is my ndvi layer, this is my ndvi, this is my ndwi. Okay, so now if you want, you can also export all of the map. Suppose I want to export for the ndwi map or ndvi map or ndbi map as a TIFF format, and then I can simply open this TIFF image in my ArcMap software and make the map layout for my research paper or other work. Okay, so now I also try to show you this part, and this is the process for the calculating any indices. not only for the ndwi, ndvi or ndvi. You can calculate it any indices. Just first of all you need to select your specific band, then you can write your equation, then it will be done. Okay, so any question in this time in here? Any question? Any question? Can you hear me? Hello? Hello, can you hear me?
Yes, sir.
Okay. So you can see here, I hope you understand this part. So now I want
Yes.
to work with this. Suppose I want to export this map as a TIFF format and work with the ArcMap or QGIS software. This is the same process for when you want to exporting this map. We can easily export this any TP